let's give a start. Good afternoon, everybody. Thanks a lot for coming today to this special seminar. It's a great pleasure for me to introduce you Rupert Stuart Smith. Well, already we are working together for 9 years, more or less, a little bit more, could be. And well, basically we started, having some discussion, and we've been working together in some work on health attribution that he will talk today. So basically, Rupert is a research associate in climate science and the law of the Oxford Sustainable Law Program. He's a geographer by degree, and he actually did his PhD there in Oxford. And his research today is about the use and interpretation of climate science evidence, identification, and methodological developments in climate change attribution science. Also do some work on climate and glacier modeling and the impacts of climate change on health. And yeah, basically has authored expert reports for climate lawsuits and work as a consultant for the Foundation for International Law for the Environment. So yeah, as you know, usually how it works, Rupert will give a talk of around 30, 40 minutes more or less, and then we will have a Q&A session. So,
thank you so much, Anna. And it's really wonderful to be here with you here in Bern and with everyone who's online. Perhaps just to start off, because it's quite an interdisciplinary talk and people split slightly from glaciology to climate litigation and the law to a little bit of a dabble in the interface of epidemiology and climate change attribution science at the end. So perhaps I could ask everyone who's in the room at least if you could raise your hand if you're an epidemiologist or otherwise in the health side of things by training.
Epidemiologist.
And we're about climate scientists, that's more broadly earth scientists. Any lawyers? No. Okay, excellent.
That one.
Anything else that anyone who didn't put their hand up? What's he? Mathematics. Pardon? Mathematics. Mathematics, wonderful. Okay, great. So a nice and diverse audience. So what I'd like to talk about today in the next half an hour or so is to start off by grounding this discussion in the context of climate change litigation, explain what that's all about, how the law is being used to address climate change. And then turn to what the role of science is in this story of how the law is being used to address climate change, and in particular in supporting what I refer to as causal arguments. And I'll come on to what that means in a little bit. And then in the second half of the talk, I'm going to turn to a more specific application of climate change attribution science and think a little bit about how the logic of climate change attribution science is used and applied when considering how we assess the impacts of climate change on, for instance, health. So extending these methods as they've been traditionally used, looking at individual weather events, for instance, to understanding their impacts. And we're going to use a case study from here in Switzerland, from Zurich, from a piece of work that Anna and I have worked on over the last few months. But before we get to all of that, I've got a question for you, and then I will actually do the lecturing rather than making you do it. But the question here is, do you think a Peruvian farmer should be able to sue a German energy company for climate change impacts happening in Peru? Is this something that you would like to see happen? Is this something you'd like to see be successful? What kinds of issues do you think might come up if such a claim is being made? Perhaps at a very basic level, do you think this seems like a good thing to do?
Yeah.
Yes.
Yes? No?
No.
Why not?
It just doesn't make sense. German company sue someone in Peru. And I think, I always think about that as well. Like, if the developed countries, they use their carbon rights and everything, like when they're developing, and now they're kind of saying that, oh, you can't do the same thing because now we have new rules. So how fair is that to developing countries at home?
Right. What if this particular German company had essentially been producing energy in Germany, that had been mining coal in Germany, burning the coal to produce electricity, earning their profits in Germany, It was just that essentially the impacts of climate change are not limited to national borders. Does that change it for you? No. Okay. Well, let me know at the end if you still feel the same way, which would be entirely fine. Perhaps the other side of the question then is, in addition to whether or not this is a good thing, something that we might want to do, what challenges do you think there might be? So this Peruvian farmer, he's saying that he is in some way affected by the actions of this company. What do you think he needs to be able to prove if he's going to make that sort of claim?
Prove the link.
Exactly, prove the link. So we're going to come on to a few of these different pieces of the story in a bit. But let's start off here in Huaraz, a city high up in the Peruvian Andes. And this photo was taken in 1947. 6 years after a devastating so-called glacial lake outburst flood from the Laguna Palcacocha just above the city burst onto the city of Huaraz below it. It killed at least 1,800 people. And this was what the lake looked like before the flood. And you see a medium-sized lake in between the terminus of this, the Palcarapi Glacier, and the terminal moraine dam, which sort of is the furthest point that the glacier had extended to in the last few hundred years. And this medium-sized lake, when in 1941 it burst, most likely due to an avalanche from the glacier, caused this devastating flood in Huaraz. But over the last 70 years, the retreat of the Palcarapi Glacier, which has retreated by about 1 kilometer, has caused the lake to expand substantially. The volume of water in the lake is now 34 times greater than it was after the floods in 1941. And the threat to the city of Huaraz is considered to be very substantial. The modeling that's been done of this, the situation shows that as many as 40,000 people live in the path that the flood would take were another flood to happen after, for instance, an avalanche or a landslide entering the lake. And over the last few decades, efforts have been made to try to reduce the flood risk. But despite efforts to drain the lake, it's still the case that lake levels remain high and the flood risk remains acute. Now, the role of climate change in this story comes in because of this gentleman, Luciano Lula. And in this case brought before the German courts, specific legal intricacies of it we'll skip over for now, but the key part of this claim is that RWE, a German energy company, are responsible for about 0.5% of historical emissions. He says, why should we, the Peruvian people in this community, why should we have to pay the cost of protecting our city against the risk of this flood? If the risk is the result of climate change, and this company is at least in part responsible for climate change, something we've contributed to hardly at all. So that's the logic they use. And as Anna said before, one of the key issues in all of this is, can you actually draw some sort of causal link between the actions of this company in Germany, their greenhouse gas emissions, and the harm that results? In the first instance, the district court rejected the case. And one of the reasons for that was because there are many, many contributors to climate change. And they said, how can you possibly pin the blame on only one company? But on appeal, the regional court in Hamm said essentially the case was well argued and asked the question, is it indeed the case that the lake actually threatens the city? And there's ample peer-reviewed evidence that said it does. And then secondly, if so, is this really climate change? Now, the answer to that second question was answered only in part and in relatively general terms in the evidence initially submitted by the plaintiff. The kinds of statements they provided was that there are no linear causalities in climate science, that only more than half of the observed warming since 1951 was due to the increase in greenhouse gas concentrations due to human activity. As it happens, that statement was taken from the fifth assessment report of the IPCC, and the very next sentence said that the best assessment was essentially all the observed warming over that period could be attributed. The statements on glaciers were similarly global in scale and relatively equivocal, and so that they are partly retreating due to human influence and that they wouldn't have melted as rapidly. it wouldn't appear that these sorts of statements have the required level of specificity to hold a company responsible for their contribution to risk on the other side of the world. So the question that my colleagues and I asked ourselves was, can we do better? And so without going into the details, because that's not the purpose today, we had a look at this situation. The kind of evidence we were able to provide was that as a central estimate, at least around 95%, virtually all of the observed warming in the region around the Paukarahu Glacier can be attributed to anthropogenic greenhouse gas emissions, human-induced climate change. And that the retreat of the glacier was a direct consequence of that warming. In fact, if you look at what could have happened due to natural variability alone, the observed retreats of the glacier simply would not have been possible in the absence of some human-induced warming. And then finally, we found that there was the consequence of this retreat, which was a kilometre over the last 70 years and roughly a mile, 1.6 kilometres over the full 150-year period of the industrial era. That retreat of the glacier has substantially increased the flood risk for Rojas. So what this story, I hope, will show is that science has an important role to play in these sorts of cases. The case has not yet had a final decision. That is likely to happen at some point in the next 12 months. But science can clarify the legal arguments that are made in these sorts of cases, and it can demonstrate that climate-mediated harms in many ways are similar to other sorts of harms that courts have had to deal with, harms inflicted by one party on another. And what attribution science methods can allow us to do is explain how in the climate context, yes, the process by which those harms occur is mediated by the climate system, but we can still develop a causal understanding of the relationship between, in this case, greenhouse gas emissions and their consequences. And one of the morals of the story that will be a constant thread through the talk is that interdisciplinary research has an important role to play in all of this. This paper, for instance, was not just a case of climate modeling, there was glaciology, there was mountain hazard research in there as well. But this is only one case. Over the last 15 years or so, we've seen a real explosion in climate-related lawsuits around the world. They've been filed on a wide range of grounds, but we're now seeing several hundred cases brought every single year, challenging in many instances government or corporate inaction on climate change, in some cases seeking to hold them responsible for the consequences of what they've done, their emissions. In the early years, these cases were particularly heavily concentrated in the US, but increasingly we've seen more and more cases filed outside the US. And in fact, some of the biggest successes in climate litigation have been seen in Europe, in South Asia, and in some of the comparatively few cases filed in Africa, as well as in Australia, and some cases in Latin America as well. But why are we doing all of this? What is the role of the law? Is the law really our best option for dealing with climate change, or would we rather that policy responds to the challenge of climate change? And the answer, in my view, is that ultimately the law is a response to governance gaps. In the first instance, you would want policy solutions to climate change, but where those policy solutions fall short, then the law can come in. What kinds of governance gaps are we talking about? We're talking about issues where policy or the implementation of policy basically leads to harms that contravene the rights of certain individuals or groups. So the law doesn't make policy in a particularly interventionist way. It's more often pointing out gaps where certain policies contravene other rights. Examples of that might be that laws contravene the rights of future generations, perhaps, or that they don't provide recourse for individuals suffering disproportionate impacts of climate change. So in the case of compensation for climate change impacts, the UN climate process explicitly rules out providing financial compensation for communities suffering from the impacts of climate change. The preamble to the Paris Agreement states that it provides no basis for financial compensation. There's also legal challenges to climate-related laws that don't address the needs of vulnerable groups, or legal efforts to address the fact that laws are introduced rather than at the level of enforcement, for instance, at the national level, but international legal instruments like the Paris Agreement and courts being asked to essentially explain what those mean for domestic governments. Laws may also fall short of specific obligations or not be self-consistent. So what we see in many of these cases is policies that, for instance, will give permission to build certain high-emitting infrastructure, expand airports, build new coal mines, and lawyers saying, oh, well, but you've got a national climate policy and this is clearly inconsistent. So you have essentially inconsistent policies that can be challenged in court. So those are a range of different ways in which the law can be mobilized to address the impacts of climate change. But the law is not only a force for good. What we've started to see in the last few years also is efforts to use the law to challenge climate policy. In particular, using something called the Energy Charter Treaty that increasingly countries, not yet clear what the implication of this is, but countries are starting to pull out of for this very reason. But this is a mechanism that some companies have used to challenge essentially governments' climate policies. RWE, for instance, went to the Netherlands and said, you're telling us we have to retire our coal power plants earlier than we wanted to. That's unfair. Please pay us 1.4 billion euros in compensation. So those sorts of cases can also be brought that could stymie climate policy or could transfer the costs of dealing with climate change from companies who invested in emitting infrastructure in full knowledge that they might not actually be able to realize the value of it onto governments. But more broadly, climate litigation seeks to reduce greenhouse gas emissions. At the corporate level, it can challenge corporate climate strategy. It can say, you need to have more ambitious climate targets. It can also challenge specific projects. Lawsuits have been brought challenging individual coal mines or pipelines. We've seen cases seeking compensation, either compensation for a company's contribution to the damages associated with climate change, or more broadly, compensation for fraudulent misleading of their investors or lobbying of governments leading to climate harms. We also see lawsuits challenging, for instance, banks' financing of fossil fuel infrastructure, and also inadequate risk management, for instance, of pension funds who plaintiffs argue shouldn't be exposing the pension fund members to risks associated with investing, for instance, in fossil fuel companies. And similarly, we see similar sorts of cases in governments, again, challenging inadequate government climate targets and challenging public financing of fossil fuel infrastructure. And this can work. So as one case study to give you, last year, there was a ruling in the Dutch courts. It was a case brought by Mario Defensie, the Dutch Friends of the Earth. And in this particular case, they argued that Shell has the duty of care and various human rights obligations to the plaintiffs in this case that mean they need to take adequate action to limit their contribution to climate change. What does adequate action mean? Well, in this instance, it was interpreted to mean they need to limit their future emissions and they need to do so in line with the Paris Agreement. And in this particular instance, the Paris Agreement, which of course is an instruction to limit warming to certainly well below 2 degrees and ideally to 1.5 degrees above pre-industrial levels, that was interpreted as meaning you need a minimum of 45% reduction in emissions by 2030. Actually, if you don't want to expose yourself to needing to remove carbon at a massive scale in the second half of the century, you probably need to cut emissions much faster than that. But minimum, most pathways in line with the Paris Agreement and the IPCC reports require a 45% cut by 2030. So that was what they asked the court. And in the summer of 2021, we got a decision. Now, Shell's executives initially were quite skeptical about the case. They described it as a noisy distraction in the Financial Times, but closer to the judgment, they started to recognize that actually the case could go either way. And ultimately, the court agreed with the arguments brought by Mario Defensie's legal team. And they said that Shell have an obligation to reduce our emissions by 45% by 2030, and a so-called significant best efforts obligation that's interpreted different ways by different lawyers. But in principle, they are meant to reduce the emissions from all the oil and gas they sell and all the oil and gas produced by their subsidiaries around the world by 45% also by 2030. And if that was implemented, essentially Shell can't continue to operate as they do today. That is the significance of a case like this. It can force companies to get on board with the transition to meeting the goals of the Paris Agreement. And a case like this also can have substantial knock-on effects. In this instance, not only does Shell need to revamp its case, but other heavy emitters, certainly in the Netherlands, but potentially elsewhere also, have been put on notice. Mario Defensie sent a letter to 29 other major Dutch companies saying, we're coming for you too if you don't get on with producing an adequate plan. And they've also threatened Shell's board members with legal action if they don't take personal responsibility to ensure Shell complies. So that's an example of how the law can be a powerful tool, potentially, for accelerating action on climate change. But going back to the issue of science and how this all fits in, there are two main types of case that I've referred to earlier in the talk. There are cases seeking compensation for countries or companies' contributions to climate harms. And there are cases seeking to accelerate climate action. And for both of these types of cases, understanding the impacts of climate change is very important. And in particular, understanding the link between greenhouse gas emissions and the harm they create. For that first type of case, you need to prove that individual companies or countries' contributions to harm actually are contributions for which they could be held responsible in court. For the second kind of case, if you're going to argue that a country or company needs to reduce its emissions more rapidly, you need to firstly demonstrate potentially that you, as a plaintiff bringing the case, are affected by the impacts of climate change. Something called standing essentially gives you the right to bring the case in the first place. And you may also need to demonstrate that failing to tackle emissions will cause harm, i.e. a successful judgment would be of consequence. So two main types of case, and the kinds of causal relationships we're talking about, factual causation as it's known in law, requires both a general understanding that greenhouse gas emissions cause climate change and impacts of climate change are of the type suffered by a plaintiff, but also specific causation. Can you link the greenhouse gas emissions of a particular defendant, for instance, RWE, through to their contribution to global greenhouse gas emissions, which combine the atmosphere, resulting in climate change as a whole, leading to the specific impacts experienced by a plaintiff? Can you basically map out that causal chain in its entirety? Can you demonstrate sufficiently strongly for a court that there is this causal link from start to finish? And the type of science that is of relevance that can answer these questions is known as climate change attribution science. And the question that's asked in attribution science most commonly is, to what extent does climate change affect the likelihood or intensity of individual extreme weather events, or for slow onset changes like glacial retreat or sea level rise? To what extent does climate change affect the magnitude of, or has climate change affected the magnitude of these processes? Increasingly, as I mentioned at the start, recent studies have sought to extend these analyses, not just from greenhouse gases emissions through to the physical hazards, how strong the storm is, how intense the heat wave is, but through to the consequences that result from them, the health effects, for instance, or the economic losses. And these studies have been embraced by the legal community as a key source of evidence for cases like this. And more over the last few years, we've seen studies conducted around the world. There's still major regional gaps, which are pretty clear from the map behind me. But we have a better and better understanding of what the impacts of climate change look like in many parts of the world. The red dots there are studies that found some influence of human activity and the intensity or probability of those events. Blue ones, which there was no human influence found. And to summarize the way methodologically this works in as brief a way as possible, really at the heart of these questions is counterfactual analysis. We can compare both transient simulations of the climate as it has evolved in response to human activity with climate model simulations of the world as it would have been in the absence of human greenhouse gas and aerosol emissions. We can also do trend-based analysis where we use observations, and based on our knowledge of how the climate system has responded to human greenhouse gas emissions, we can strip out the human-induced contribution to warming. And using these sorts of methods, using these approaches, we're able to answer the questions of the change in intensity or the change in probability of extreme weather events. But using this sort of evidence in court is, of course, not simple. One of the issues that can arise is the fact that we're talking about the contribution potential of an individual country or an individual company, not climate change as a whole to its impacts. How does this work? It's not the case that one storm is caused by Exxon, the next by Shell, and the one after by Chevron. But all greenhouse gas emissions combined in the atmosphere results in climate change as a whole, which may then amplify individual events. And this fungibility of greenhouse gases both is a problem, but also a problem with the solution. The courts have in the past, outside of the climate change context, dealt with situations where there are many contributors to problems, and they've come up with ways of apportioning or allocating responsibility in spite of that. They call it market share theory, and that's exactly the logic used in the case study I presented at the start. RWE's 0.5% contribution to historical emissions can be used to hold them responsible for 0.5% of the costs resulting from impacts. The second issue that you might think would be a potential stumbling block is that extreme weather events are not a new phenomenon. They've always happened. We've had storms, we've had floods, we've had droughts, we've had heat waves. What climate change may do is make them, as I say, more intense or more likely. Is that an obstacle to establishing causation? The answer is it might be. In some instances it is, in some instances it won't be. But the courts are also well versed in dealing with probabilistic evidence in many settings. And in that sort of way, the courts have developed legal tests for causation, tests like the doubling of risk test that would establish a causal relationship between the action of a defendant and the impacts on plaintiffs if the defendant can be shown to have doubled the risk of harm taking place. And the third potential problem is that attribution findings can be sensitive to choices in methodology. They're subject to uncertainty. How exactly you conduct the study and how exactly you should interpret its findings is, of course, a problem that's common to many forms of scientific inquiry. This is something that perhaps hasn't been explored as much in these cases yet, but I think perhaps the most simple way in which this can be resolved in many instances is, yes, attribution findings may be subject to some uncertainty, but we can quantify those uncertainties. We know where they come from, we know their magnitude, by and large. And if we can quantify those uncertainties, then we can assess how sensitive our results really are to uncertainty. And if we can show that there's still a substantial role for climate change in spite of potential uncertainties, then it may still be sufficient to establish a causal relationship in court. But now on to the new bit that Anna and I have been discussing the last few days. One of the interesting insights from extending attribution analyses beyond just looking at physical hazards alone, as I said before, the intensity of storms, droughts, floods, and through to looking at their impacts, for instance, the impacts on health, is that it really matters whether or not you look at intensity or probability. Now, you can imagine it would be an issue if you have two equally legitimate representations of the effect of climate change on a weather event. One side could use one explanation in court and the other side could use the other. There was, for instance, a heat wave that happened in Japan in 2018. A study came out that found that the heat wave was so intense it couldn't have happened in the absence of climate change. The study also found that the equal probability heat wave, it was whatever it was in the current climate, say 1 in a 100-year event, the 1 in a 100-year heat wave in the absence of climate change would still have been very hot. would have been a few degrees cooler, but people still would have died. So is it the case that climate change is entirely responsible for this event, or that climate change actually just made it a bit hotter and caused some extra people to die who otherwise wouldn't have? And the difference in interpretation is potentially legally relevant and important. And what I would, on the board, there's a different example from a heat wave in France, but essentially the same story. You can do these studies in different ways, and you can get potentially qualitatively different insights into the effects of climate change. But crucially, when you're looking at the impacts of climate change, these formulations are not equally valid representations of what's going on, in my view. So if you're extending your analysis to look at, for instance, the health impacts of heat, many relationships between the hazard and its impacts are continuous. It's not either that you have a heat wave with lots of deaths or no one dies at all, but rather the hotter it is, the more deaths occur. And because you have continuous relationships between temperature and mortality, or indeed between the intensity of a storm and the economic losses that result from it, intensity-based metrics, reasons I'll come on to, better represents the effects of climate change on its impacts. And this has implications for the types of causal tests you would use, and it's something that the legal community hasn't really engaged with yet. Typically, they've focused on these probability-related, probability-based framings of attribution findings. Now, two reasons why intensity-based metrics are a better representation of the effects of climate change. The first is that when we talk about probability-based metrics, typically the way these studies are done is they say, what is the chance of having temperatures, for instance, of 27 degrees or hotter in the present climate or in a natural climate? And what they're actually comparing is the probability of essentially all of these events that didn't actually happen, that were hotter than the real events, in the tail of the distribution here, in the present climate and in the natural climate. And so you have in that a whole range of probabilities of events that didn't actually cause harm, that were more extreme than actually happened. In a recent paper, Sarah Perkins, Kirkpatrick, and others, they basically describe this as the problem of focus on a class of events rather than the specific event that actually happened in practice. And the other issue is that because these relationships are continuous, it's important to understand just how much worse, for instance, 1 degree increase in temperatures in the heat wave actually makes the impacts. So if you use this intensity-based approach where you say, how much colder would it have been in the absence of climate change? How much less intense would the storm have been in the absence of climate change? If you know what the relationship is between the heat and mortality, for instance, then you can quantify the impacts associated with it. And your results will be sensitive to the shape of that exposure response relationship. Probability-based assessments, by contrast, essentially bundle together all the impacts that occur below the thresholds and create a binary situation where either the harm happens or it doesn't. And so for that reason also, it's important to, or it's a more accurate representation of what's going on, to use these intensity-based approaches. This is what it would look like. Essentially, you have here, this is the cumulative probability of events of different intensities in a natural climate. In blue, you have the cumulative probability in the present climate. And you see that for an event of equal probability, you have here 1 degree of warming. So it's 1 degree hotter for the equal probability event. And the effect of that increase in 1 degree in, for instance, mortality is this, whatever this is. This is just a sketch, but it shows how you would do this sort of analysis. What you need to be able to do it is this relationship between the magnitude of the hazards and the impacts that result from it. Now, conscious of time, I'll hurry up a little bit because I don't have much of it. But what this means is that the attribution question becomes, how would the magnitude of the impacts be different if you have the same likelihood events happening in the absence of climate change? And as I say, you need the hazard impact relationship, which sounds like a non-trivial requirement, and it is indeed a non-trivial requirement. And I can confirm this, but my suggestion is that you basically would need the same data to develop that relationship as you would to quantify heat-related mortality in general. So in many situations, this is not necessarily introducing a major new data need, though not to dismiss it as nothing. But to finish up with a case study of the work we've been doing, and I will rattle through this quickly so we have time to discuss. But the context is coincidental. We actually, when we had chosen the case study, we weren't aware that this would be relevant for this case, or potentially relevant for the case. But there's an ongoing case at the European Court of Human Rights in which a group of elderly Swiss women argued that essentially they are exposed to dangerous effects of extreme heat, violating their rights under the European Convention on Human Rights. And they're asking the European Court to instruct the Swiss government to increase the ambition of its climate policies to reduce emissions more rapidly, to limit the exposure that the Swiss government's emissions are creating, or Switzerland's emissions more broadly are creating in terms of increased exposure to the dangers of extreme heat. And in order to bring the case, the plaintiffs need to demonstrate that they are particularly affected by the effects of extreme heat, climate change's contribution to them, and that the increasing temperatures in Switzerland due to climate change is already dangerous. And so what we looked at was whether we could quantify heat-related mortality attributable to climate change in Switzerland over the last 50 years, over 1969 to 2018. And in addition to that full time series of data, we looked in particular at the summer of 2018, which you may remember was particularly hot. And we wanted to understand there what the effect of heat waves really are. Is there substantial heat-related mortality attributable to climate change outside of the heat waves too? And the fact that most attribution studies have focused on extreme events in particular before is it actually missing out some of the impacts of climate change that occur outside of those extremes. And lastly, we wanted to look a little bit at what the effect of adaptation might be in terms of reducing heat-related mortality. Now, because of time, I shall be fast about this, but one of the important methodological refinements we made in conducting this analysis relative to other studies was that we wanted to use observed temperatures as the main temperature time series from which we could generate estimates of heat-related mortality, and compare that to a counterfactual time series where basically we strip out the climate change contribution. So the use of models rather than estimating heat-related mortality in pairs of factual and counterfactual model time series. We use those pairs, but to generate counterfactual by essentially subtracting the difference between models with climate change and without climate change from observed temperature data to get the counterfactual temperatures in Zurich. And based on that data, we were able to quantify the effects of climate change on heat-related mortality. We found that across the 50 years, 1.7% of all-cause summer mortality could be attributed just to the effect of climate change on raising temperatures. And very similarly to Anna's study that was published last year, we found that 34% of heat-related mortality could be attributed to climate change in the canton of Zurich. There was, of course, some variability between different data sets, and of course, this is not constant between years, but the implication of 2,000 deaths attributable to climate change over 50 years is that on average across that full period of time, around 40 deaths per year are attributable to climate change. Whether that sounds like a lot or a little to me, it sounds like quite a lot. These are just the impacts of climate change, raising temperatures in the summer, and that alone is enough to kill in Zurich alone 40 people per year. And one way to contextualize this is that there are quite a few companies that have contributed at least 2.5% to historical emissions. BP is one of them, and 2.5% of 40 is one death per year. So on average, across this 50-year period, a company like BP, their emissions alone are enough in Zurich alone from raising summer temperatures alone to contribute 1 death per year. And Zurich's population is about 1/5,000th of the global total. So that starts to give you an insight into the potential scale of the impacts derived from emissions of greenhouse gases, even from individual companies. We also looked at heat waves, and what we found was that, of course, mortality peaks, heat-related mortality peaks during heat wave periods, but actually in orange you see the attributable deaths, so that's heat-related deaths attributable to climate change. In black you see heat-related deaths not attributable to climate change, that would have happened in the absence of it. And actually the proportion of deaths attributable to climate change are higher outside of heat wave periods than during heat wave periods. And that's for the simple reason that in the context of a concept of a minimum mortality temperature, climate change is, if it's responsible for instance, a degree of warming, that 1 degree makes a bigger difference, a bigger portion of the difference between the observed temperature and the minimum mortality temperature at temperatures closer to the minimum mortality temperature than at hotter temperatures. But at the hottest temperatures, of course, in absolute terms, the total amount of heat-related mortality, including heat-related mortality attributable to climate change, is highest. And then the final point is that we also wanted to have a little look at roughly how we could understand what the effects of climate change adaptation might be. So there are various things going on, and it's in Zurich, of course, and we weren't able to disaggregate them precisely. But we know that demographic changes can, of course, change populations' vulnerability to the impacts of heat, as can changes in infrastructure, changes in behavior, etc. And we know from Evan's work that demographic changes should have increased population vulnerability due to aging. And so if we were to make the assumption that we thought was reasonable that the other sorts of changes, changes in infrastructure, changes in behavior, could be broadly termed as adaptation-like actions, even if they weren't necessarily intentionally to reduce vulnerability to heat. The net effect of those actions was to substantially reduce the mortality associated with heat in the last 15 years. In fact, we found that under a scenario in which we excluded the shift in vulnerability to heat since 2003, that caused an additional roughly 1,300 deaths to occur. So there's an indication there that even in a place like Zurich, where relatively limited measures have been introduced actually to reduce, intentionally to reduce vulnerability to heat, it's still the case that populations can at least reduce some of those impacts, which is a positive insight, although still there's much more detailed work that could be done that would more properly disaggregate really the causes of those changes. But overall, what we see is that climate litigation, as I mentioned at the start, can really be a powerful tool for action on climate change. And a key source of power in climate litigation is scientific evidence. Scientific evidence, in particular evidence from attribution science, can form a firm factual basis for these sorts of claims to be made. One of the types of attribution science evidence that's increasingly important for these sorts of claims, especially as more and more human rights-based arguments are being brought in climate change, is attribution of health impacts. And in our work, we've sought to refine those methods to synthesize better methods from climate science and methods from epidemiology to be able to most accurately, most robustly quantify the health impacts of climate change. But there are still big gaps. There are large regions of the world where relatively little research has been done on the impacts of climate change. And to some extent, that is due to inadequate data availability, but opportunities to fill those gaps could also provide opportunities for cases brought on behalf of some of the most vulnerable communities in the world. So there's a lot of value in that also. But, and perhaps the final thing to say is resolving or increasing the success of climate litigation is not simply a task for science. there's, of course, major legal hurdles that need to be overcome too. But if we can get the best scientific evidence in place and make sure that this is available in these sorts of legal settings, then that at least gives these cases a fighting chance of success. So with that, I've got slightly less time for questions than I hoped, but still perhaps 15 minutes.
Okay, thanks a lot, Rupert, for the nice presentation. Yeah, probably we can give a bit of time for questions. If anyone in Zoom as well, wants to raise a question, just put it in the chat, please. So anyone, yeah.
I feel like there was just one missing thing from this last part that you put into your talk. Is that the value of human life in court systems? The value of human life is usually around $1 million US.
Around how much?
Around $1 million US.
$1 billion US.
$1 million.
$1 million.
1 million.
1 million. Right.
$1 million US.
Yeah.
That's often in the case of like negligence and stuff, and then there's actually payout in that sense. So the fact that you can connect BP, I think if I remember correctly, to 1 death a year, I mean, essentially what you're saying is that BP owes $1 million a year to Zurich and everything. So I don't think, I don't know. It's when you start putting it that way, and you start putting all the numbers on the board, the actual financial risk to these companies is absolutely enormous. I don't think they even understand like how big the risk is to them, other than that they might be trying to everything they can to block them off.
Well, it's certainly true that financial risk to companies is very large. Quantifying the value of human life is a bit of a can of worms, and there are good reasons why the IPCC, for instance, doesn't do it. And I think it was in the second assessment report where it was raised that essentially the economic methods used to work out how much the dollar value of a human life should be involved essentially going around to different parts of the world and asking people how much money they would pay to extend their life by a year, for instance. And unsurprisingly, people in the US gave a bigger number than people in some other parts of the world. And so the consequence of that in the economic literature was that Americans' lives were valued more highly than people in other countries. And when people started to wake up to that, they realized that actually there was no genetic basis for that, and it was plainly ridiculous in many ways. So the economic value of human life is a bit of a can of worms, but the broader point on the financial risk associated with climate change is a really important one. And I would even go as far as to suggest that fossil fuel companies, for all the massive profits they've raked in over the last 150 years, net, I think they've been value destroying. And there are sort of simple back of the envelope ways in which you can start to demonstrate that point. But the one way you can do it, for instance, is to take the social cost of carbon, which tries to bundle together all the economic impacts of emitting a ton of carbon to the atmosphere. And we know that many of the biggest fossil fuel companies have emitted to the atmosphere tens of billions of tons of carbon dioxide over the last 150 years. And if you multiply those numbers by normal values of social cost of carbon, $100, $200, $300 per ton, the numbers you get actually are typically bigger than the profits these companies have made over time. So that indicates at least that these companies have caused a lot more harm than they've ever gotten profit. They just socialize that harm. They allow others to pay for the consequences. But more practically, you can see, rather than perhaps quantifying through number of people killed, take Hurricane Harvey that hit Texas in 2017. and Dave Frame and some colleagues did a study on that event after it happened. They found that of $90 billion in losses sustained during that particular event, about 67 billion could be attributed to climate change. And if you take their results and you do essentially what we did with the BP example earlier, you find that a company like Shell, responsible for 2.1% of historical emissions, 2.1% of 67 billion, I'm not saying this off the top of my head, I did it before, is about 1.4 million, I think $1.4 billion in damages. So one company like Shell alone, if they were to be held responsible for their contribution to an event like Hurricane Harvey, we're talking about $1 billion of damage for individual emitters. If they were held responsible for 2 such events a year, that's not implausible. We could start to see successful legal judgments like that. A few $1 billion a year in compensation, even for a company like Shell, that's 10% of their annual profits gone. So yeah, financial risk is really substantial in these cases, and it turns emissions into liabilities. If you turn emissions into liabilities, then the profit-seeking motives of companies potentially goes out the window. So the profits from digging up fossil fuels and selling them to others to burn can evaporate too.
Yeah, some questions to elaborate on that. So, as you already mentioned, there are multiple events in 1 year, right? So, like you can have a hurricane, the floodings in Pakistan, the heat waves, also mortality. So, if a jury, like if the court basically rules guilty to this stuff, does that mean that for like every company who has been part of this, they would also have to pay their percentage? And then at that point, like what is left of, of course, the economy is still there, like because all those big companies, they all go bankrupt in that sense. So it's not a sustainable way of going after companies. So rather maybe you will go, instead of paying the cost, like is it better to, for example, adhere to the Paris Agreement, which was the other way of going after companies and having like, is that like, how would a court think about those sort of consequences of making one ruling over another ruling?
Well, it's a great question which has many parts to it. I think that perhaps the simplest bit to answer on the what is the consequences of this? Someone's paying for the consequences, and personally, I think there's a pretty decent moral case to be made that large fossil fuel companies should pay for the consequences of the harm rather than Peruvian farmers with essentially no historical emissions. So that's sort of a moral case. In terms of whether or not we should be holding companies responsible for their historical contributions, we're telling them to get on with fixing the problem, reducing emissions more rapidly. Definitely, we need that transition. Of course we do. We need to prevent further worsening of climate change impacts, but that doesn't eliminate the moral problems caused by historical emissions, especially when you can prove, or in many of these cases, they seek to prove that these harms were foreseeable consequences of emissions. These companies actually knew, as well as anyone, what the impacts of greenhouse gas emissions were going to be. They covered up the science, they polluted anyway, and then they lobbied politicians to stop them from interrupting business as usual. So there's plenty of decent moral arguments for why this all seems like a good idea. And then on the first question you asked, which was, so what does this mean for the other companies? What does this mean for the other impacts if you have one successful case? It's not entirely clear, but I think the first thing to say is precedents can play a powerful role. If you have a successful case in Germany, then other German companies are definitely on notice, and you would expect to see similar rulings on similar sorts of cases based on similar arguments with similar sorts of evidence in future. So the success of one case can pave the way for future successes of others. But what that means for companies operating in different jurisdictions is less clear. So you do sometimes see courts citing decisions from other jurisdictions, especially if they're from sort of related legal families. But so for instance, common law jurisdictions, you can see quite a lot of sort of cross-fertilization. But exactly what a ruling in Germany against a German company means for Dutch companies operating in the Netherlands or English companies operating in England, that is less clear. And so that precedent won't necessarily mean that all the non-German companies who have contributed most of greenhouse gas emissions would necessarily be held responsible for the impacts of their emissions.
We have 3 questions here in the chat, and maybe Sonia, you were the first one raising your hand. Try to speak up. I hope that the sound works here.
Where does the sound come out?
I hope you can hear me. Does it work out? Yeah, thanks a lot, Rupert. That was an excellent presentation, really interesting. I've actually more of a small understanding question. In the case study of Julia versus RWE, you mentioned that the first evidence, I don't know, I think you cited, I guess, from the first court decisions, there are no linear causalities in climate science. And then in the second evaluation, I think you provided more detailed numbers, but I don't remember that you mentioned some kind of debunking of this statement, because actually we can demonstrate that there are some linear causalities also in climate change. Many of the relationships are linear. So I don't know if you can comment on that point.
I missed just, sorry, my hearing isn't so good, so it's a little bit difficult. It's me, not you.
It was about the, there are no linear causalities in climate science.
Yes.
Yeah, and you don't seem to have basically addressed this specific point in afterwards. You rather said, okay, we provide more detailed, more specific estimates of the contribution, but the specific point, I thought this came from the first judgment. Is that correct?
Actually, I think you were coming out from over here. So the question's about whether there actually are linear causalities in climate science?
No, because there are. I mean, that's my point was there are. So I mean, if this is a criticism, I think we can debunk this criticism easily, because there are linear causalities. Yeah.
Yes, well, quite exactly. And so really this was just, so there are linear causalities in climate science, and for the other statements, we can do better. We can be more specific than in practice they were in the evidence provided. And so I think all of that just goes to show that, these sorts of cases do need access to the best available science if they are to have a chance of success. And in the absence of engagement of really the people who are at the forefront of the field and can contribute that sort of insight, the judges would be forgiven for thinking actually that climate science perhaps is more uncertain than in practice it is. Or they might be forgiven for thinking that in reality these relationships are less clear than in practice they are. And so I think, these are examples of just why it is important that we really get the right evidence in front of courts.
Yeah, thanks a lot,
Yeah, sorry, I hope I heard your question correctly. I'm now going to stand next to where I think the sound's coming out of.
Yeah.
Oh, this one's written, that's even easier.
Yeah, exactly. This one is from Samuel Lute. Hi, Rupert, thanks for your talk. Many current lawsuits are aiming at energy companies. How would you see the odds in going to court against banks that finance fossil infrastructure, which is probably more the case in Switzerland?
So this is definitely, we're seeing the start of a trend in cases like that you may be familiar with the concept of scope 3 emissions. In the case of fossil fuel companies, scope 3 emissions are emissions produced not directly by their operations, nor by the electricity, the energy they consume, but by either upstream or through the products they sell. And similarly, their efforts to essentially frame financing as scope 3 or even a new scope of emissions. And so more and more cases challenging bank financing, trying to hold banks responsible for the emissions associated with projects that they fund. There's, if you are interested in some examples of that, then feel free to drop me an email. My email's on the screen. And I don't think I've got any cases off the top of my head, but this is definitely a trend that is increasingly being pursued in climate education. It's worth saying in Switzerland, there is actually one case that has been filed seeking compensation for climate impacts, which is really the second big one outside the US other than Luya. And that was, and perhaps someone here can correct my pronunciation, but it was brought by 4 Indonesian islanders against the Swiss cement manufacturer Holcim or Holcim? Holcim. And they, I believe, are the biggest emitter of greenhouse gases, at least historically in Switzerland. And that case seeks a range of remedies, but and to some extent makes similar sorts of arguments to in Luya.
Just quickly to the last because we are running out of time. This one is from Charlotte Planner. What role do you see for this sort of scientific evidence, not just to retroactively assess accountability of states or private sector actors for climate-related damages, but also to preventively inform forward-looking policy and legal reform? And it's a bit more longer, but.
Okay. I think the most, it's certainly the story of the use of climate science in the courts is far from limited to attribution science. In terms of climate change impact science, projections are also crucial for explaining to courts how future greenhouse gas emissions, unmitigated, would cause substantial harm. But there's also a range of other needs for different types of scientific evidence. One source of scientific evidence that we didn't speak about today is the modeling of climate change mitigation scenarios, asking how much carbon can we add to the atmosphere and meet the goals of the Paris Agreement. And that sort of evidence is similarly important in terms of communicating to companies, to governments, and ultimately to courts what they need to be doing. But unpacking the nature of those sorts of mitigation scenarios is a complicated question that's both, or it is as much a moral question as it is often a scientific one. How much are we willing to allow action to be delayed and then to rely on carbon dioxide removal to take back some of those emissions in the second half of the century, for instance? If the answer is not at all, that has substantial implications for how rapidly we need to cut emissions now. So yeah, I don't know if that's so much an answer to the question, but there's a range of different sources of scientific evidence that can be called upon. And as legal argumentation continues to evolve, then we would expect to see potentially new needs for new types of scientific evidence that we may not have looked at yet.
Well, yeah, unfortunately we have to close the session today. Well, thanks a lot, Rupert, for the nice presentation, for being here today. I hope you can come in the future again.
I'd love to.
And yeah, if anyone's interested in contacting Rupert, you have his email there. And yeah, if you are also interested in the work that we are doing, of course, we'll be happy to talk to you. And yeah, thanks a lot.
The last question, or do we need to leave the room? Or
no, well, actually, I have to be in my office in 10 minutes because I have an interview with a Spanish speaker. But yeah, we can stay for a while. Otherwise, Rupert can stay.
Just this case about the canton of Zurich is really interesting. So how sensitive is that analysis to the spatial scale? So where you draw the borders of the system. What would you expect if you did exactly the same analysis just for the city of Zurich with the heat island or the heat island and so on? Would you expect a higher rate of attributable mortality, or not really, because the urban heat island was always, and that's a kind of a natural phenomenon and not attributable to CO2 or greenhouse gas emissions?
Well,
actually, in the study that one of them, the multi-city study, we included the city of Zurich only, and the effects were slightly larger, and very slightly,
not substantially.
No, and in my opinion, I think, of course, in terms of number of deaths, it will be incomparable to the population, will be more, because just the city has more population against the whole canton in terms of it's more dense. But I think that based on the data that we have, we cannot really measure the effect of urban heat island. But I would say that on average, it should be very similar. Of course, if you compare cities like a big city with very rural locations, you will find differences. But just expanding the region, I don't know to which extent it will have a strong impact on the estimates, I think.
I can also add a little bit to that. In the community land model, part of the community earth system model that's in the IPCC report, in the RCP 8.5 scenario, so the really high scenario, 8.5 standing for the 8.5 watts per meter squared that's coming from CO2 gases. In the urban areas, you also have on the order, due to air conditioning, of 4.5 watts per meter squared coming from the air conditioning waste heat. So in a sense, that is something that can be, might be something that could be used in that kind of calculation on projections, is saying that not only do you have the CO2 radiative forcing that's quantifiable, but we can also add in the counter to that heating, the waste heat that's being produced by the energy use of air conditioning that would amplify the urban heat island.
I mean, at some point,
it's not very linear.
In a way, our final calculation depends first on the difference between the two scenarios. So if you expect larger impacts in the city, so the difference between the counterfactual and the factor should be larger on one side. And then on the other side, you should expect that the vulnerability of the population in the city is larger compared to the rest. This is something that we test in Evan's paper, that actually cities against rural regions, cities are more vulnerable to heat. I don't know to which extent for the city of Zurich, actually, this difference is going to be much larger compared to the boundaries. The other question, I don't know, maybe it's more for you, Rupert, it's really this difference between the two counterfactuals would be, in a way, larger in the city versus a wider region. I mean, I assume so, no, because it's the same delta somehow.
It's interesting because actually the delta intensity is less sensitive than the delta probability. So if you were to do the probability type assessment, what you typically see is that an extreme event that happens might be really extreme, and it depends on the question, but it might be really extreme for a particular location. But when considering the region as a whole, actually it's a hot summer. It just so happened that for a particular location, and that is the hottest temperature. So it could be that it's particularly extreme at the particular region, but the change in intensity is more consistent. I think the heat island effect is whether or not that's considered to be a natural process, or whether that's something that should be included as sort of the anthropogenic contribution to what's changed over the industrial era.
I think that's a big question. Down the road, the big question. I mean, the smaller in scale you go, say the smaller is the fraction of vulnerability. And if you're in a smaller area, then the fraction of unforced variability is smaller, so attribution would actually be much more difficult to get. And then at the same time, you have them say with say the growing city, you have a larger effect of the heat island, which is attributable to construction and not really to say to of course that that goes in the same way, but not really to greenhouse gases. So I could imagine that if you go to smaller scales like a city, this would in fact be much more difficult to attribute, say, mortality to greenhouse gas concentrations. And
I mean, methodologically, of course, you can see that probably there are sources of bias, and eventually the problem of all these stories is that you have to prove this link. First, the link between heat and mortality, and then the second link between this heat-related mortality with climate change. And whatever you can do to simplify these paths will help drawing the whole story. But I mean, I see some drawbacks and advantages when going into smaller scale, larger scale. Larger scale at the same time, there are so many things going on at the same, you know. It's like when we did the analysis, multiple locations, we gave a number of 30%, but people say, oh, but you didn't account for this. Oh, but in this place, why is that? So I think it's a bit more, yeah, I can see the pros and cons for both things, honestly. I don't know, from the legal side, I don't know what is the experience.
Well, I mean, on the legal side, I don't think courts have really engaged with those sorts of nuances very much yet. But if you have sophisticated defendants who are able to pay smart scientists to poke holes into these sorts of things, then yes, I think it's something to be aware of. But you know, there's so many parts of the question that actually are often not properly resolved in these analyses. How you account for land use change, including urban heat island effect, how you account for local aerosol emissions. For instance, there are studies that, taken at face value, appear to show that climate change isn't making heat waves hotter in parts of India. Actually, global climate change is. The effect is just masked by local aerosol pollution, but that doesn't mean that global greenhouse gas emissions aren't making it hotter than they otherwise would have been. And so how exactly you ask the question, whether you include those local factors or not, is important and often isn't properly properly interrogated in the way that some of these analyses are done.
Do you think it would be worth, I'm just thinking about this urban heat island effect. Urban heat islands compared to the land, they have always been, it has always been the same. So natural variability due to this was always much larger. So it might be different, more difficult to get, say, 2 days variability with climate change to differentiate that statistically from the larger variations in the past. And if you go to, say, to smaller scales, you get, say, a number of, say, other factors like air pollution or whatsoever, which is, if you have a large ensemble, this is balancing each other out. So you would get more robust numbers.
Yeah, probably, but I must say,
would that be worth looking at kind of systematically? How, say, if you do the same analysis for the city and for a larger kind of trying to factor all this out with
the problem we can, and actually we are now doing similar analysis, but for the whole Switzerland for the last year and for the last summer, sorry. But still, I think that it's not a matter of the dimension or the geographical unit that you assess. It's more the assumptions that you put in place when you go into one unit of geographical unit or another. In terms of, okay, we take a larger region, but we assume the same vulnerability to everybody. Is this good? Is this bad? Of course, when you go a small scale, you can refine that. And you know that the exposure response for, let's say, the vulnerability that you estimate is a good proxy of this population, because in a way you make it more homogeneous. On the other side, it's true, when you go small scale, there might be some confounding factors that in large scale will be diluted. Yeah, but at the same time, in a large scale, you don't have such control of other potential factors that can happen in terms of misclassification of the exposure, whether the resolution of the data is enough, things like that. I mean, I don't know, honestly. Sorry that I need to leave, but you can stay here, Rupert. I'll be in my office, but you can just come back. Okay, sorry. Thank you for coming.
Questions, please. But it's like more about like methodological and also like kind of philosophical question.
Yeah.
So like I was thinking about the example that you gave at the beginning. So what you're doing basically, you have the aggregated data, and you are saying that trying to make casual interpretation from the aggregated data, saying that a certain company should be accounted for a certain event somewhere in the world, right?
Yeah, but I mean, the lawyers are trying to do that. It's not, yeah, I'm merely the scientist, but,
right.
But yes.
But still, the issue that, like, I'm not talking about the methodological issues. I think like there's, like, you can't really do that in, can't really reach the resolution without like individual level data. This case would be like individual level of that company data to that country, sorry, not country, company to country. So the main issue is that if they decide to say, yes, there is a causation, and let's think about another example, like heat wave in Japan, right? One, and I remember your paper too, it caused like excess mortality and morbidity. Then if there's this causation and it's established, someone who was affected by that heat wave, let's say had a heart attack and had to use medication for rest of his life, can't that person actually see that company as well? Because there's a causation between the heat wave and morbidity and heat wave with the company. And then the person, I had this health issue, so I'm going to sue this company because they result in the heat wave. Wouldn't that be possible as well if we go to that direction?
So, would it be possible to, do you say a company who would produce aerosol emissions?
Yeah, so they result in heat wave in Japan, and we are establishing or that, yeah, there's a causation.
Yeah.
And we punish the company or whatever. And then there's some people affected by that heat wave,
yeah,
and had some heart issues. And can they actually, based on this conclusion, can they sue that company as well?
I mean, potentially.
Principle, yes.
And
I think that is precisely what we have seen in this, in the smoking smoking issue a couple of decades ago in the US.
Passive smoking.
Passive smoking, and passive smoking, according to Neumireskis and others who have studied this whole thing, she would argue that, say, the law cases with passive smoking were the game changers in the whole issue.
Yeah, yeah.
Because once it has been decided that, others can follow in principle.
Yeah.
And I think that would be my other question. I mean, say historically, we the problem on climate was recognized, and we said we need better science, we need better numbers, we need reducing uncertainties, and that is what we did for 10, 15 or 20 years, and then nothing changed, and then we thought, well, we need to put values on the damage, getting the economists on board, didn't change anything, and then we were told scientists should better communicate, and we communicate on perhaps nothing. And I think we are now saying with all this, the rapidly increasing number of these cases in various aspects, they all have kind of a different DNA in how they argue, depending on the kind of the legal. In Switzerland, we don't have a constitutional court. You cannot say file say a case against the constitution. It's not existing in Switzerland. So all the cases in the specific country content, how do you call this?
Context?
Context, yeah, context, not content. The specific context, they look all different.
Yeah, and actually the point you made about tobacco actually comes back to your question, Evan, to some extent, which is, so what's the end game for this? And tobacco is one possibility where we saw, following successful cases, eventually government stepped in, and essentially they stopped the cases, but they introduced some regulations. But lots of people still smoke, and tobacco companies are still very profitable. We also saw cases against asbestos, companies who exposed people who then contracted mesothelioma to asbestos. And in those cases, ultimately, that led to a ban on asbestos.
Yes.
And so I think the end game with these cases ultimately is not that it's in some way feasible. I mean, climate change impacts happen all around us all the time. we can't have millions of cases filed every year. The courts won't manage that. So the likely route to impact is that some initial positive decisions ultimately lead to some sort of legislative response. But the nature of legislative response, that's almost the most important moment. Still fine about sort of triggering that. But is it just going to be that governments essentially shut up the movement for compensation, or that they provide a more orderly, organized process by which compensation for climate harms can be delivered? Or that they shut down these cases, but they just introduce much firmer climate policy for future emissions. What government's response will be to these cases? There will be something if they succeed. What it will be is unknown.
I'm thinking about like from the company perspective, and for example, your case is saying that like 2.5%, 2.1% emission by your company. And cat companies, I feel like they can easily say that we are emitting this much of gas because aerosol, because we have consumers who have demands. So we are actually somewhat reliable on that as well. I'm not obviously like releasing 2.1% of global emission, but I'm doing like 0.001% because I'm flying there, flying here. And isn't that like
flying?
I'm not actually flying. I'm not that. I'm a PhD student, but like some people do, right? But yeah. So aren't we actually responsible as well? And aren't we?
And so, I mean, that's what these companies, of course, claim. They say we're providing a service that people demand. They buy our products, they want it. It's not our fault that they decide to go around burning the carbon we dig up from the ground. And yeah, arguably they have a case. But the argument that's used in response is that actually it's not, in general, individual consumers deciding how their stuff is made. These companies, knowing what the impacts of their products would be, firstly, chose to produce products whose correct use involves dumping massive carbon into the atmosphere, and then secondly, lobbied governments to prevent climate policy that could have led to a transition in which stuff would be made without these emissions. So essentially, they were, through their actions, in the driving seat that determined what our energy system looks like. And so for that reason, they have responsibility associated with those activities above and beyond the responsibility that we as individual consumers have.
Right. Thank you so much. Yeah, that was all my questions. It was really fun. It's not an area, but just
In your case with Zurich, I'm sure you have some data kind of aggregated by age. I mean, the klimasenioren case.
Yeah.
The question is it true that elderly women are more affected than young men? Or